Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with orthographic front view, top view and left hand side view projections corresponding to an engineering object. Now corresponding to the orthographic projections, we are required to obtain 3D isometric projections of this engineering object in which the front face, the top face and the left hand side view face, all these three faces of this object, they will be combined into a single 3D isometric projection over here. So now in order to convert the orthographic projections into the 3D isometric projections, we are required to convert the true length dimensions available with us into the orthographic projections available over here into the isometric length projections over here. So all the true length dimensions available with us in the orthographic projections, they will be plotted alongside the true length scale and the corresponding isometric length dimensions we are going to evaluate. So now let us evaluate the dimensions of the front face, the top face and the left hand side view face over here. So as we can check into this orthographic projections, into the front view, the length of the object happens to be 90 millimeter, height of the object happens to be 40 millimeter. And now we are going to obtain this front view face alongside the YZ plane over here. So alongside isometric z-axis, the length of the object will be obtained. Alongside the isometric y-axis, the height of the object will be obtained. So far as the top view projections they are concerned, so we know that the length of the object will be 90 millimeter and the width of the object will be 70 millimeter. So this is the x-axis which is going to depict the width of this object over here. This is the z-axis which is going to depict the length of the object. So therefore, alongside this XZ plane, we are going to obtain the projections corresponding to the top view of this particular engineering object over here. So far as side view is concerned, so we know that the dimensions of the side view, they will be measuring 70 millimeter will be the width which will be available over here and 40 millimeter will be the height. So on the left hand side we can check alongside X and Y plane over here. So we are going to obtain the left hand side view face of this object now by using the information available with us through front view, top view and the left hand side view. We are going to project the 3D isometric projections corresponding to this engineering object over here. To begin with, we are going to convert all the true length dimensions available over here into the orthographic view into the isometric length dimensions over here. At an angle of 30 degree, we are going to draw the isometric x-axis and the isometric z-axis over here. So alongside z-axis, we are going to plot the length of the object. Alongside x-axis, we are going to plot the width of the object and alongside isometric y-axis, we are going to obtain the height of the object over here. So as we have discussed, alongside x-axis, we are going to obtain the width of the object which is equal to 70 millimeter. Alongside z-axis, we have obtained the length of the object. So length of the object happens to be 90 millimeter. Now we check that the height of the object happens to be 40 millimeter. So this height has been obtained onto the isometric y-axis which have been obtained over here. Now we know that once we are going to draw the isometric projector line over here measuring 90 millimeter and this isometric projector line will be parallel to the z-axis. Similarly, again we draw another isometric projection line measuring 70 millimeter and this will be parallel to the x-axis over here. So we are able to obtain the top view projections corresponding to the base of the solid over here. Similarly, once we draw another isometric projector line over here which is measuring 40 millimeter and parallel to the y-axis, and we draw another isometric projector line which is going to measure 70 millimeter parallel to the x-axis, we will be able to obtain the left hand side view face corresponding to this object over here. Similarly, once we draw these two isometric projector lines over here, this projector isometric line happens to measure 90 millimeter and it is parallel to the z-axis over here. And this isometric projector line, this happens to be parallel to the y-axis and it measures 40 millimeter. So now the front view face corresponding to the solid, it has been obtained over here. And again, if we draw two isometric projector lines over here, so this isometric line, it is parallel to the z-axis and it measures 90 millimeter. And this isometric line, it measures 70 millimeter. It is parallel to the x-axis or this isometric projector line. We are able to obtain the top face projections into the isometric projection view over here. And finally, we have drawn another isometric vertical projector line which is parallel to the y-axis and it is again measuring 40 millimeter. So this way, we have been able to obtain a cuboid into which the front face, the left hand side view face and the top view face corresponding to this engineering object construction has been obtained over here. Now let us divide this component into multiple elements over here. As we go through the orthographic projections of this object into the front view, top view and the left hand side view projections over here. Now we can check that this object can be divided into two elements. The first element, it is a horizontal wave which is lying at a height of 20 millimeter from the base. So we see that this horizontal web, it is available at the base of the solid, and onto this horizontal web we have got a central rectangular slot available with us, and we are going to have these two inclined faces into this horizontal web which we have been able to obtain over here. Similarly, corresponding to this vertical web which is available over here, this vertical web is available at the rear face of the solid. So this is the rear face of the solid. So onto the rear side, we are going to obtain a vertical web over here, and into this vertical web, here we have got at the center an angular slot which has been provided over here. So once we are able to identify these two elements, so one by one we will be proceeding to evaluate the construction of these two elements of this engineering object over here. So now to begin with, we know that the height of this horizontal web, it is available with us as 20 millimeter. We know that this height is available over here into the left hand side view orthographic projection view as 20 millimeter. Now a ring we have constructed over here which will be parallel to the base of this particular solid. So now onto this ring, different elements, that is this inclined surface, and this rectangular slot will be obtained. Now another information we have got into this horizontal web from the rear face of the solid in front of the rear face. So this portion of the web will be a straight line portion over here. We can check at the front side also, at the rear side also we have obtained a flat surface starting from the rear side and from the front side of the solid also. So here we are going to have a vertical surface. What is the size of this particular vertical surface? The length is equal to 40 millimeter, height is equal to 20 millimeter. So height is equal to 20 millimeter we have already obtained. Now we are going to measure a length of 40 millimeter from the right hand side face of the solid. Now we obtain that. So from the right hand face of the solid, as we are going to move towards the left hand side face, which is this face over here, we observe that 40 millimeter from the right hand side face, this surface happens to be a straight surface over here. So now we have measured this length of the surface as 40 millimeter. Now this isometric projector line we have drawn parallel to the y-axis, and the height of this edge, it is equal to 20 millimeter. And then we have drawn a horizontal projector line over here such that this portion of the bottom web, this will be straight one. And now we know that there will be two inclined faces over here. So now we have to project these distances over here into the front face of this particular isometric projection construction over here. So into this front face isometric projection, now we will observe that if we are able to plot the location of this point corresponding to the inclination. So we know that the distance of this point, it is 15 millimeter from the rear side, and again it is 15 millimeter from the front side over here. So 15 millimeter from this point and 15 millimeter from this point. So this inclined surface and this inclined surface will be obtained over here. So we also know the thickness of this web over here. So what is the thickness of this web? So we know that the total width of the solid happens to be 70 millimeter. So out of the 70 millimeter, 15 millimeter plus 15, 30 millimeter means this is the dimension corresponding to the two inclinations. And then corresponding to this rectangular slot, we have got the width of the slot equal to 25 millimeter. So 30 plus 25, it makes it 55 millimeter. So it means that this dimension will be 7.5 millimeter and this dimension will also be 7.5 millimeter. So now you can check, we have marked 15 millimeter. One point we will be able to locate corresponding to this inclined surface over here. 15 millimeter over here. One point we have been able to locate corresponding to this inclined surface over here. And then 7.5 millimeter will be the width of the web. Over here 7.5 millimeter will be the width of the web over here. So that the width of this rectangular slot, it will be equal to 25 millimeter. So now we can join this inclined surface corresponding to this portion of the web over here. So corresponding to this portion of the horizontal web, we have obtained a vertical wall available with us into the front view construction projections over here. Similarly, corresponding to the rear side of this inclined web, now we can join this portion over here. So another thing we know, there is going to be a rectangular slot over here, and this particular rectangular slot length happens to be 30 millimeter, width happens to be 25 millimeter. So this width we have already obtained over here as 25 millimeter. So now the length we have measured as 30 millimeter corresponding to this rectangular slot. So what we can do, we can draw one isometric projection line over here at a distance of 30 millimeter from the face. Now from a height of 20 millimeter, we have measured this distance is equal to 30 millimeter, and now this width is already available with us as 25 millimeter. So now from this point, if we are going to draw a projector line which will be parallel to the z-axis, again we can draw another projector line which will be parallel to the z-axis. So wherever these two isometric projector lines, they are going to intersect with this isometric projector line which was earlier drawn at a distance of 30 millimeter from the face of this particular solid over here. So now this rectangular slot location we have been able to obtain into the isometric projection. So this is the top view projection over here corresponding to these projections. Now at the bottom we are going to obtain one isometric projection line parallel to the y-axis, one isometric projection line parallel to z-axis over here, another isometric projection line we have drawn parallel to the x-axis. So this completes the projection of this rectangular slot which is available onto the left hand side portion of this particular engineering object over here. So this way element number 1 construction into the isometric projections it has been completed. Now let us proceed with the construction of element number 2, which happens to be a vertical web which is available onto the right hand side portion of the solid. So if this is going to be the front face, so onto the right hand side we know that the thickness of this vertical web, it happens to be 15 millimeter. So once we know the thickness of this vertical web, now we can check. We have marked the thickness of the vertical web over here as 15 millimeter. And what is the height of this vertical web? So we know that this horizontal web, it was having height is equal to 20 millimeter. So the remaining 20 millimeter out of this 40 millimeter, which is going to be the height of the object. So the height of this vertical web will be 20 millimeter. The length of this vertical web, it will be equal to 15 millimeter. So we have marked the length of this web is equal to 15 millimeter. Now we will be drawing another projector line over here which will be parallel to the x-axis over here. Similarly, from this point we are going to draw one vertical projector, another vertical projector measuring 20 millimeter. From this point we'll draw one vertical projector parallel to the y-axis. From this point another vertical projector we will be drawing parallel to the y-axis, and this distance will be how much? This will be equal to 20. So now we can check this front face of the vertical web we have been able to obtain over here. And what are its dimensions? Height is equal to 20 millimeter and width is equal to 70 millimeter. The width, it is equal to 70 millimeter and the height, it is equal to 20 millimeter. So this vertical web which is available onto the right hand side portion of the solid has been obtained, but this is the uncut portion of this vertical web, whereas we have observed in the side view projections that there is an angular slot available over here into this vertical web in such a way that the width of the top portion of this slot happens to be 18 millimeter, because this distance is 26, this distance is 26, so this makes it 52 millimeter. So out of 70, so remaining distance becomes 18 millimeter over here. So now we are going to plot the top portion of this particular angular slot into the isometric projection. So from the rear face, this distance is 26. From the front face, this distance is also 26. Now we can draw two isometric projection lines over here which are going to represent this portion of the angular slot and this portion of the angular slot over here. Now we know that at the top this width happens to be 18 millimeter, whereas at the bottom the width has been provided to us equal to 30 millimeter. That is, this distance will be 6 millimeter, this distance will also be 6 millimeter. Now we know that at the bottom side of this angular slot, so this width we have been provided as 30 millimeter, but this bottom of the angular slot, it is not lying at the base of the solid, it is lying at a distance of 5 millimeter above this horizontal surface of the web over here, or it is going to lie 15 millimeter below the top surface of this particular solid. So either way we have to draw a projector line over here which will be parallel to the x-axis, which will be 5 millimeter above this horizontal surface, or it should be 15 millimeter below the top surface of this solid over here. So So now we can check. We have got the linear measurement corresponding to this angular slot at the base of this slot equal to 30 millimeter. So this width from the center we have marked as 15 millimeter from the center on left side, 15 millimeter from the center onto the right side, and where this 30 millimeter base of the angular slot will be obtained at a distance of 15 millimeter from the top face. So now one projector line we are going to obtain over here. We can check 5 millimeter from the top face of this horizontal surface or 15 millimeter below this top surface of the solid. So one horizontal projector line we have drawn parallel to the x-axis. Now onto this horizontal line we are going to obtain the bottom of this particular angular slot. So what we are going to do, the total width of this edge happens to be 70 millimeter. So we are going to find out the midpoint 35 millimeter from either end, and from the center 15 millimeter towards left, 15 millimeter towards right. So 2 points we have marked over here, which will give us the base of the angular slot measuring 30 millimeter at a height of 5 millimeter from the top surface of this horizontal web, or 15 millimeter from the top surface of this vertical web over here. So let us now complete the remaining elements corresponding to this angular slot of the vertical web. So we had obtained this angular portion over here. So from the rear end of this particular slot, in a parallel projection line parallel to this face we are going to obtain, and from the top face another isometric projection line we are going to obtain over here, and one more isometric projection line we are going to draw parallel to the x-axis, so that the rear portion of this angular slot we are able to complete corresponding to this edge, and this edge. So this way we have been able to complete the construction of 3D isometric projections corresponding to this engineering object. So let us start with joining of the different faces which will be visible to the observer from the front face, left hand side face, and the top view face over here. So we can check into the front view. This face is visible to the observer. So we have joined this L shape projection corresponding to the front face over here. So the true shape of this surface was available with us into the front view projection over here. Now this face is also visible to the observer into the front view, but since this is an inclined surface, so the apparent shape of this surface is visible to the observer into the front view projections over here, and corresponding to this slot here we have got a dotted line over here. Now corresponding to this face, now we are going to obtain the left hand side face over here. So corresponding to left hand side face, we can check this portion will be visible to the observer as an apparent shape. So this is the apparent shape corresponding to this inclined vertical web over here. So here this portion will be visible to the observer as a true shape. Similarly, this portion of the rectangular slot, it will be visible to the observer as a true shape over here. And again, this portion is also visible to the observer as a true shape over here. And this portion of the inclined web is visible to the observer as apparent shape over here, because this is inclined portion. So this portion will be visible to the observer as apparent shape corresponding to this inclined web. And over here we can check this is the top face which is available to the observer as a true shape over here. Similarly, corresponding to this portion, we are able to observe true shape representation of this portion into the top view projection over here. And corresponding to this base, this is also visible to the observer as a true shape. Whereas this inclined web and this inclined web over here, so this inclined web, it is visible to the observer as an apparent shape. This inclined web, it is visible to the observer as an apparent shape over here. So this way we have been able to complete the construction of the 3D isometric projections corresponding to this engineering object, for which the front view projections, the top view projections and the left hand side view orthographic projections, they were available with us. So this is all for today. We are going to continue with further discussion regarding few more illustrative cases of isometric projections in the coming lectures. So thank you very much. Thanks a lot.